So we are starting. Hi guys, nice to meet you here. My name is Arthur and I'm software engineer in Scala24. Selling platform in Europe and all our backend stuff we are doing on Scala. So today I will talk to you about my own experience with building of purely functional application based on free algebra and what's the difference today topic and all the done years before about free monods. Everything was based on functional primitives like cats and scala. There was a lot of problems with boilerplate code and increasing of development time. A more major solution for writing free algebra programs on Scala. It's called Freestyle framework. It's, first of all, it's a core part. It's a bunch of matrices that help you to reduce boilerplate code, so you can write just without any problems. And second one, it's different integrations to 10 or 15 libraries like akka, play, sleek, and so on. Not to care about infrastructure and just to write your own code. So let's start. Is to make a short kickoff to functional programming. Effect concept, and I will describe how to handle side effects in the proper way. Most important, tooling that will help of free algebra programs without any boilerplate is and with fully testing and fully testable unit tests. Today's agenda is introduction to FIPI, just very shortly. Introduction to free algebra, what is it, how it's working. Part it's hands-on experience with Freestyle library, where I will show how exactly program with it, and we'll define some result in the end. So, what is functional programming means? Functional programming became kind of a buzzword where everybody using it without proper understanding of domain. When we are talking about it, it's way programs when we are instead of imperative state mutation, when you have some global variables that mutating through all program execution step by step, we provide composition of functions that just evaluate input data. Advantages of usage of functional programming approach is that we getting preferential transparency. It means that we can predict what will be the result of our function execution. We know what exactly going on just by the name of the function, and we will not be in trouble when our state become inconsistent or invalid and so on. As you saw in the start of webinar, we told that we will write pure functional program. And what pure is? What means pure? It's a subtype of function, but with two additional features. That a pure function guarantee idempotency. It's just a guarantee that says that we will get the same value, same result of the function, with the same arguments multiple times. It means that we can easily cache and memorize result output of the function based on the function arguments. You can easily test such kind of software because every part of it will be quite predictable. You can predict all the corner cases that your function will, and pipeline will be error-prone. Also, when you have this kind of guarantee, it means that you are unable to operate with global state. You will not have any problems with this kind of stuff. Is a guarantee there are no side effects performance inside. And what the side effect is? Actions that operate with some stuff outside of the function scope. We operate with side effects in our day-to-day developer job. For example, every time when you console, rendering something in the DOM tree in the browser, manipulate with files, changing database state, some other I/O, you're doing a side effect. It's really important stuff because nobody cares about software that don't have input place and output place. So the trick is that we all want to do the side effects, and there is no way to avoid it. I think that when somebody asks you how they can avoid the side effects, it's not really the right question. Be how we can manage the side effects in the proper way. Of engineering, and it sounds like postpone all critical decision till they really need to be done. It means that idea-wise, we shouldn't think about the effect that we want to choose, or everything about our program. For example, to choose database from the start. We don't want to choose some queue providers from the start. We want to develop as much as possible till we will get all the information about our business domain to choose the effect that we want to have. So, manage effects properly. We want to have a guarantee that our effect will be executed sequentially, that our program will be stopped till it will be done, and only after the effect will be finished and we will get the final result in execution of our program. We needed to avoid different kind of side effects and so on. So currently we reach the point when all the good speakers trying to tell some joke. It's needed to relax attendees before complicated stuff. I'm not so good on that kind of stuff, but I just found a good picture that describe experience of Java developers when say trying to learn Scala. Might have guessed, we come to the point when we will speak about the monads. I'm not feel inspired to describe what is a monad from academical point of view. Tons of different talks on the topic on the internet, but there are only one thing that we should monads. Monads provide us a guarantee on sequential effect execution. An example that you can't see on the screen, listings that operate with try monad. Monads that have exception catching, that if exception will be thrown, then it will stop execute functions in the next one .map.fatmap calls. And as you can see in fourth line, we will really throw exceptions, so fifth line will not be really never reached. And with help of it, we can guarantee that, okay, our previous action was executed without any runtime exceptions. So currently, we resolved a part of our problem. Now we have guarantees that, okay, effect, we will continue execution of our program, will be finished. But we are still bounded, and we can decide which one to choose. The last step, we should write all our code base from scratch with some specific monad, try, future, ID, and it's not really what we want to have. What we want to have, we want to monad choose the effect only in the end when we are really executing our program. Talk about free algebra and free monads. What free algebra is? Algebra, it's a language on top of your language. Talking about some free algebra semantics, we're talking about your own domain-driven language directly for resolving of your business problems. For example, model our program on some very high-level components. For example, if we want to do some validations when we save user, we will say that, okay, in first step, I get in the user request. In second step, I validate it. In third step, I check in it with state of the database, into the database. And in fifth step, I send some results to customer. Currently, we define it 5 different steps. that can be our free algebra. The trick is that later on we want to execute it time delay, and we want just to, when we are programming, we want to just to set the sequence of the actions that should be performed, but execute it only when we will be ready to do it. So it's where free monad will be helpful for us. What free monad means? Free monad means that it's monad free from effects. We don't have inside of it only one thing that free monad does, the list should be performed. And later on, give us ability to interpret all of it with some effect. Let's take a look at an example. As you currently can see, we have the same code semantic. We have this execute method that's applying try effect on our program and execute it. We can, with the trick, we can guarantee that our business logic will consist from composition of pure functions. When we will start dealing with IO or some another effects, we will really apply the effects on our pure functions. Now we have some of what is free algebra and free monads. I think it's time for showing off. We will not have live coding, but we will have something like that. And we will have quite interesting topic. Let's imagine that we are working in some and major and the core part of business of music streaming company is reporter to the record labels. When you start listening music in iTunes Music, in Google Music, in your application sends an event to the server that says that some song started playing, and when you stop at it, the backend also know about it. It's needed to make an invoice from record label provider, from record label, on which one Spotify, iTunes, and so on will play. So our role is to write applications that will consume that kind of events, calculate amount of time which one music was played on, and then report it to some abstract record label. So here are our project, and as you know, every project, it starts from build file and from library dependencies. To our project, we will add Freestyle core model that provide us all the useful macroses and implicit stuff that will be useful to write our code. We will have Scala test to test our implementations, and also we will have Scala Meta Paradise. It's a compiler plugin that adds really useful and fancy macroses that are used by Freestyle core. Our plugin to use Freestyle core. Also, in your real-world application, you probably will add here different Freestyle modules, like Kafka module, some module, play module, and so on. Let's move on. First of all, we want to define what we will support. As I talked before, we will support stop at event that just tell us which one user started which one song playing and from which one point of time this song is playing now. And we'll have some stop at events as they're doing exactly the same, but also reports as finish time. So we will know this period of time in which one song was played to report it. And also we will have that will events. We will need it because our consumer will be infinite recursion function, infinite loop. And we should somehow stop it. It will take the events till it will not receive that PL. So it's technical reasons. Now let's talk about our free algebra, about our algebras at all. As I defined it before, with free algebra, you're creating your own top high-level abstraction language, provides your real business action. They doesn't care about real technical implementation. It just a definition of what your program will do. So we have three types of algebras. And consumer, it's algebra that will work on consuming the events from somewhere. We will have player state storage. It's algebra that will copy the state of player of our customer. And we will have record label provider, reporter. It's algebra that take care about reporting the results to record label. If we will take a look on our player event consumer, we will see that it's like regular Scala trait. First one with free annotation that we got from Freestyle package. And second one that there are some tricky FS wrapper on top of player event. So what we expect from this one poll event method? Executed, it will return to us some player event with which one we will operate later on. But let's dive a little bit deeper. Freestyle is reducing the amount of boilerplate code significantly. So let's just expand the macro. Boom. As you can see, there are lots of stuff that probably you will need to write by yourself if you will want to write your code in functional way. But what is really going on here? So when we define the trait, we define some kind of interface with which one we want to work. But under the hood, this poll event call will not be really in some handler. What will be done when you will call this poll event? It will generate some poll event operation, part of our free monad. And later on, when our free monad will be fulfilled with all the actions, we will have some implementation of handler in the scope, which one will be used to interpret this kind of operations. So when you call poll events, it creates the poll event operations that will be stored in free monad. It will interpret our free monad. It will use implementation of handler, where we will define the real reaction on poll event operation. With the trick, we will be able to postpone execution of our program. Let's hide everything. Yep. So let's talk a bit more about our algebras that we have. Also, we have player state storage. Player state storage have two actions, two operations. Indicate when some playing started. Sorry. First one indicate when song playing started. And here we we will just save the information about starting time and anything. And when song playing finished, we will get the information about that we got in first one action and calculate the amount of seconds which one song was played. Just report that information to record label reporter. So nothing complicated, just like simple logic. Issue that in program, we probably will need to do some complicated grouping of our operations because this operation that belongs to player event consumer, our poll event operation. This operation that belongs to player state storage, also different domain at all. And record label have the same stuff. So use all the three algebras together into the model. And in the model, we will have a group of operations of all these three algebras that's already aliased, and we can just any headage. So currently we have the model that's just the algebras that was defined before. And we will use this model to write our program. Let's take a look how our program will look like. We will not implement our program fully. See how we can write this program. So what's going on here? We have event consumer program. It's an object, not a class as Scala application, because only pure function. They will not have any effects outside. It will not have. It will be just general definition of programs that we want to execute. Our label recording loop. and different strange things you can see. First one is that f, generic f with gap. This one generic should be fulfilled with operations that we want to execute. So for example, in that case, we want to execute all the operations that are in model. So we will provide here finally consumer context.op. It's like this coproduct of all algebras that we have. Next one, we have implicitly put it here, consumer context. It will be fulfilled by the Freestyle library. So we should not care about on which one place we will get this consumer context. We will just get it when we will start execute that function. The function, it's our free monad. Operate with operations of consumer context, and as a result, it returns unit, because currently we just have a loop that's just doing her stuff and don't care about the results. And then to use some part of our algebra, for example, here I've written just one line to show how it's working. We call it our consumer context, taking algebra in which one we're interested, and then just call the method. With that kind of syntactic sugar, we can think that here we're just calling the function, but as a result, in call will be not the execution of real implementation of function. There will be just an operation to our free monad. We can operate with also with the result of functions that we defined before. So we can do everything that we can do with just plain functions. Changes that we've done. And now what we want to have, we want to have kind of a test, which one that we want to have in our web or recursion loop to have an ability to interpret it later on. So let's check out the test. Yep. So here our event consumer program test. What it's really doing? We expect that event consumer loop after song was stopped. First of all, we will define list of events. We will define list of events. First one will say that user start playing song from starting from 10 seconds on 15 seconds. Then he continued playing from 15 seconds, and then he stopped on 25 seconds. And also we will have a dead pill. It's like end of execution. Result, we expect that in reports we will see that song was played firstly 5 seconds, playing also 10 seconds more. And now it's exactly the time to describe how we can execute our programs. Our label recording loop that we programmed before, and parameter, as I talked before, we're providing the coproduct of operations that we have in current model. So for context.op, it's a group of all the operations that we support in. And later on, we have this magic method .interpret ID. What it doesn't mean? What does it really mean? So when we call for .interpret, it starts searching for implementations for handlers for our algebras directly for ID effects, where it takes these handlers in our case. It takes it from where I defined it before. And here we have 3 handlers for all our 3 algebras. For example, when we're talking about player event consumer, we'll create a new handler of player event consumer for just like ID effect mean ID effect of nothing. Some kind of wrapper that provide us quality on top of everything. So we use it just to cast our data to monads. And instead of ID, there can be future, try, and so on. It depends on which one effect you decided to choose here. So in our player event consumer handler, we overriding poll events where we're saying that, okay, if somebody trying to pose an event, we will take the first one element from event sequence here and return it to the execution flow. All stuff is in record label reporter. We're just creating new instance of record label reporter, of handler of record label reporter for ID effect. And here we override report method that we defined it. It looks like we defined it here, but it's totally different class convention. Set to the report sequence. Third one handler, it's player state storage handler, place where we will copy the logic of our client. So every time a client will start listening music, we will from this one state, and when he will finish, we will be able to calculate. We will just take the start time, remove from it, and with help of finish time, we'll calculate the total time at all. And if we had some problem, for example, we don't receive a song playing started events, finish time, it's also okay for us. Problems that if we are talking about, it's really mocked handlers that don't have any behavior under them. So it's, but when we are talking about per state storage handler, we have some business logic here. And later on, we will need to write the handler for our production environment. And probably here will be not the ID and not the memory state. Here will be a future effect, be somewhere in database and so on. So we need some kind of test that will guarantee that our for in-memory stuff will have the same behavior as a handler for production database, for example, Postgres. So for that kind of stuff, we will create separate test for our algebra, and it will be a bit different from what we saw currently. Create some test spec from test spec is an abstract class. It cannot be executed, and it defines your test cases in general. These test cases should be applied to every implementation of player state storage handler that we will have. This program that just calculates that when song was started and after that was finished in 15 seconds, result. And here we have small difference in the way how we interpret our program. So we still have some test programs that we interpret with operations of player state storage, but then we don't call interpret function like we done it before. Because interpret, it's quite specific stuff that will be custom for every handler that we will implement. So for example, when we are talking about in-memory player handler, here we just imported our handler flow and our interpret method with program.interpretID. And do it here because we want to be independent from FX. So currently we're just using our feature to selection to write the program, and only when we will need to execute it, select effect for testing. Here we saying that, okay, in our in-memory player state storage test, I want to execute, define it on top of it in spec. And it should be interpreted as with ID effect. And that's all. Later on, we'll add our, I don't know, production, Postgres, future, play, state storage handler. We'll probably have dot interpret future. And it will be a specific part that are related only to current implementation. Two tests. First test is for our play, state storage algebra and our program itself. And what's the behavior we expect? We expect that one test will fail because that tests in memory handler should be okay because we already implemented it. And second test should fail because we don't have implementation. And as you can see, we know that, yeah, our player state storage is working correctly, and consumer don't have any reports. It's not really working. Okay. Now we reach the point when we have some way to determine is our program written in the correct way? Is it result our business problem? So it's time to really implement the program and to show how it will look like. So let's check out the implementation part. Yeah, now we have here a little bit more code. We just doing a poll effect, poll event, but later on, some sum function, handle player events. So handle player event, it looks like our label reporting loop, same as before. Currently, it accepts one more parameter, event, that we provided in our call. And what to do is pattern match the events. So in case of we start playing the song, it will just go to play state storage and call the song playing started operation. In case of song stopped, it will go to song playing finished. It will go to play state storage and say that, okay, song playing operation is finished, song playing finished, and I want to get some song playing time to record label reporter, get song play time from our previous action to the record label. That both of its events have a recursion recording loop, and general can be that we will trap into Stack Overflow error more or less soon, because it's not really and yeah, but Freestyle, one of the features that when we are using this free monods, we got trampolining from the core, just like for free. So what is trampolining? It's a way to optimize recursion to not to troll Stack Overflow exception. It's not going for free from performance point of view, but it had to think about it. When we receive the despill, we just return in unit, nothing. We just finishing our program. So currently we define it, all the actions with which we want to operate. We define it the programs that are totally pure. They don't have any side effect and any dependencies. They don't know with which one databases, with which one. They just know that, okay, I want to execute this list of high-level function, high-level operations. Our test where we provided the handlers for these high-level operations, which one will be used to interpret this program. Now we see that all tests passed. So currently we executed our pure program with effect of ID and with logic that we have in all our operations. The result, we end up with a program that don't have any boilerplate code. You just, like when you write in your programs with Freestyle, you really prototype this. And later on, thinking about implementations of this prototype. And all the stuff that should be generated around is generated by Freestyle. We got support of stack safe recursions out of the box, just because Freestyle supported. Proper FX handling out of the box. As you can see, for example, in test for algebra that I described before, we can choose the effect only in the point when we will really need to decide which one effect we want to choose. Base is fully testable. We can test our algebra separately. We can test our program separately. We can test wherever we want separately. We will be safe when we will compose everything into our final solution. So, some takeaways. You will be possible to find these links in the description to YouTube video, to YouTube stream. A free thing that might be useful for you if you feel inspired to try it by yourself. Website of Freestyle framework. On that website, they have quite good quick start guide. They have a definition of all their modules that they support and quite rich documentation. So if you will stuck in some stuff, probably you will find the answer on your question. Blog post from John DeGoss that describe the idea. It's exactly what we reached by usage of Freestyle framework. And third one, it's a great talk that was done on Elix Scala conference, where you can find some ideas and underhood stuff that was by watching this talk, you will understand some kind of decisions that was taken in this framework. That's all, folks. I was glad to present you my ideas about the way how you can write purely functional application. Hope you feel inspired after my talk. And if you will have some questions, feel free to ask me on Twitter. You can see my Twitter handle in the bottom, Arhemus. Questions, and thank you for your attention.
Thank you, Artur, very much. Let's wait for some questions, maybe a couple of seconds. If no questions right now, so we will finish. So guys, feel free to get in contact with Artur after the webinar using Twitter and other channels. Thank you so much. See you next time on our webinars. Bye. Get in contact with